Okay, linear thermal expansion. Most solid materials expand or contract depending on their temperature. As temperature increases, object expands. As temperature decreases, the object contracts. This is referred to as linear thermal expansion. To the extent at which something expands or contracts, we can match it with the property of the material. So if it's a copper rod versus a brass rod versus a lead rod, we can figure out this common thing for that material. We're going to call that alpha in this case. Alpha is going to be our thermal expansion coefficient. And then we have the change in length is going to be whatever the original length was times alpha times the change in temperature. Change in temperature doesn't matter, Celsius or Kelvin, because it's going to be the change in temperature. So most substances expand when heated, and change length and volume is typically proportional to the change in temperature. So the proportionality constant is called the coefficient of linear expansion. So here's some common ones: lead, aluminum, brass, copper. Things don't change very much for things like glass, but things can change considerably with materials like lead or aluminum. I guess we have concrete here, so we could have an example with that. Bimetallic strip consists of two metals of different coefficients of thermal expansion. So if you heat them up or cool them down, their lengths are different when they change, and so you can get a bending involved. Thermometers are devices that are used to measure temperature, use some physical property that is temperature dependent. So length or volume, or we'll talk about electricity and magnetism later on. In that case, we'll talk about resistivity, the ability to conduct electricity through the material. So most common thermometers are based on linear thermal expansion. I guess technically it's volume. So a mercury thermometer or an alcohol thermometer, when you put the thermometer into something that is at a different temperature, it will change in length or volume, and what we're reading is the length on in the little tube. Objects expand in volume as well. Beta here, our volume thermal expansion coefficient, is 3 times alpha. It's just alpha in 3 dimensions, or we could do things in 2 dimensions and have the change in area. So it doesn't matter which axis we're in, the length of the material is changing either 1-dimensionally, 2-dimensionally, or 3-dimensionally. There's thermal expansion. Okay, the exception to the rule happens to be the most ubiquitous substance on Earth, that is water. Water has a maximum density at 4 degrees Celsius, after which, when we cool it down further, it becomes less dense. So it goes from expanding to contracting when we get down there. It goes from contracting to expanding when we get down there. So the deal with water is that when it goes from a liquid to a solid, it becomes less dense. The density changes, and the water will turn into a solid substance that is less dense than the liquid. And as it's transitioning, as it's going from its maximum density at 4 degrees down to its less dense form, it will become less dense. All right, that's enough of that for now.